Welcome back to Boson Buzz. I'm Monty Molecule. Look up at the sun. That immense sphere of plasma in the sky is the fundamental energy source for our planet. For billions of years, it has been fusing atoms together in its core, releasing the energy that lights and warms our world. Its process produces minimal emissions, with high energy density, and is fueled by the most common substance in the universe, hydrogen. For decades, researchers have worked toward developing compact fusion systems here on Earth, fusion reactors that could provide substantial, low-risk, low-emission energy. The technical hurdles have been significant, requiring large-scale facilities and extremely high temperatures. But what if we could modify the parameters? What if, instead of constructing massive fusion devices, we could develop rapid, small-scale systems repeatedly? This is the story of an alternative, more agile methodology applied to this fundamental cosmic process. This is the pursuit of contained fusion systems. The goal is to heat a cloud of hydrogen fuel to over 100 million degrees, turning it into a whirling soup of particles called plasma, and then use incredibly powerful magnets to squeeze and hold it steady long enough for atoms to fuse. It's like trying to hold a lightning bolt in a magnetic bottle and convincing it to stay put and simmer for seconds or minutes. It's an engineering marvel, but immensely complex and huge. The new thinking asks a brilliant question. What if we didn't need to hold the lightning bolt at all? What if we could just create a tiny, perfect flash of fusion, harvest its energy instantly, and then do it again, millions of times a minute? This is the philosophy of inertial confinement fusion, or ICF. Instead of magnets, it uses the power of sudden, immense pressure. The box, in this case, is often a hollow gold cylinder called a hohlraum. Inside it, suspended by the finest threads, is a peppercorn-sized pellet of fuel, a frozen mixture of heavy hydrogen isotopes. This pellet is the miniature star-to-be. The walls of the box are then hit simultaneously from all sides by an unimaginably intense pulse of energy. In the largest experiments, this energy comes from the world's most powerful lasers, their beams focused to a pinpoint. In newer, compact approaches, it might come from a blast of intense particles or a sudden electrical discharge. The moment of creation is breathtakingly fast. In less than a billionth of a second, the lasers vaporize the inside of the gold box, creating a bath of searing X-rays that uniformly crush the fuel pellet from all sides. The pressure is like that at the center of a giant planet, applied in an instant. The pellet's outer shell explodes outward violently. According to Newton's law, for every action there is an equal and opposite reaction. So the rest of the fuel is driven inward in a perfectly symmetrical implosion, compressing it to densities greater than that of the sun's core, and heating it to fusion temperatures. For a fractional moment, a tiny, contained flash, a miniature star ignites. Hydrogen atoms are forced together to form helium, and in that process, they release a burst of energy. The trick is to get more energy out of that flash than the lasers put in to create it, the holy grail known as ignition. Recent breakthroughs have shown this is possible, but the next step for a practical power plant is where the true innovation for a sun in a box comes in. The vision is to turn this single, spectacular experiment into a reliable, rapid-fire engine. Imagine a reactor chamber where fuel pellets are dropped into the center, one after another, like precision-made icy pearls fed from a high-speed hopper. Inside the chamber, a system of powerful lasers, or perhaps a new generation of compact particle accelerators, stands ready, synchronized to a rhythmic pulse. Think of it not as one giant camera flash, but as the relentless drumbeat of a hummingbird's wings. A barrage fires, pop, 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 igniting a miniature star every fraction of a second. Each micro-explosion is a contained tiny fireball that poses no threat to the robust chamber walls. Yet together, their combined energy is immense. Each pulse releases an intense flash of heat and neutrons against the chamber's inner wall. This heat would be captured by a swirling protective blanket of liquid metal, like lithium, flowing inside the chamber wall, which gets very hot and also breeds new tritium fuel from the fusion neutrons. This continuously hot liquid metal is then piped out to a standard heat exchanger, where it boils water to create steam and spin turbines, generating steady, grid-ready electricity, just like in a conventional power plant, but with a fusion core that is clean and inherently safe. The advantages of this approach are profound. It's inherently safer than traditional nuclear fission. There's no risk of a meltdown because the fuel is only a tiny pellet, and the reaction stops instantly if you stop dropping pellets. It produces minimal, long-lived radioactive waste, and its fuel is derived from seawater and common metals, enough to power civilization for millions of years. The box itself, while high-tech, could be far more compact than a fusion power plant based on giant magnets. We stand at the threshold of one of humanity's greatest achievements, not just understanding the stars, but learning to borrow their blueprint for a peaceful, prosperous future here on Earth. The sun in a box represents a shift from building monolithic, cathedral-like machines to engineering precise, repeatable, and manufacturable stellar sparks. It's a future where our energy doesn't come from digging, burning, or splitting, but from a process of gentle, controlled creation, the same one that powers the galaxy. It's about bottling a piece of a star's heart to light our homes, and in doing so, securing a bright, clean future for all. From the heart of stars to a chamber on Earth, from monumental machines to rapid-fire stellar sparks. That's the audacious promise of the sun in a box. It reimagines the quest for fusion not as building a captive sun, but as perfecting the recipe for a momentary brilliant star and then repeating it with the steady rhythm of a heartbeat. It's a future where clean, abundant power is literally created from water and light. If the idea of harnessing star power in a compact, safe machine fills you with wonder, please help Boson Buzz fuel this vision. Give this video a like and subscribe for more stories of cosmic scale innovation. I'm Monty Molecule. Until next time, have a safe and curious week.